Hey guys, this is Unit 2, notes number 1. Okay, so we're diving into rational equations and everything related to that. Okay, so go ahead and write down your FLT here and then press play whenever you're ready. So, your goal for the day: given a rational equation, I will be able to solve it with consideration of its domain. So, to be honest, it's really nothing new. Maybe just a little bit more, but it ties into what we learned in the last unit, okay? All right, so here we go. First, what are rational equations, okay? So, the word rational comes from the word ratio. You might have heard that word before. A ratio is like... let's see, for every 2 strawberries, there's 1 blueberry. Okay. For every pizza you have 5 hamburgers. So 1 pizza, 5 hamburgers. So a ratio is really just a fancy word for fraction. Okay, so when you guys see the word rational just means fraction, okay? So we're dealing with equations that have fractions in them, okay? And I'll show you guys a very easy way to take care of it, but also we want to make sure that we consider the domain, okay? So remember, domain helps us make sure that we don't use any values that aren't supposed to be used. Okay, and we'll talk about that in a second once we dip into our first problem here. So go ahead and write that down, including the directions, okay? Press play whenever you're ready. Okay, so here it says we want to solve for all values of x, okay? So when you guys get into higher math, you want to be able to solve pretty much any type of equation here, okay? So again, this is a rational equation because you guys see fractions. You see something over something, okay? Okay, the first step. Now, I know some of you guys have seen this in Integrated Math 1, maybe even Integrated Math 2, but I am going to show you how to do this a little bit differently only because it will help you guys in the later lessons, okay? Some people like to jump into solving right away, okay? The first step, and I'm going to write this out because it's super important. The first step to really any problem is to check the domain. And I'll show you why this is beneficial when you're solving these equations, okay? So here's a quick review on domain. The domain is the set of all possible x values, okay? So the only time something can go wrong is if you're dealing with 2 things. You're dealing with square rooting some type of negative number, or you're dealing with dividing some number by 0 when 0 is underneath, okay? So if you take a look here in our problem, we don't have any square roots. So we don't have to worry about that. But we do have fractions. And more importantly, we're concerned with the denominator. We want to make sure that our denominators do not come out to 0. So here's what you guys do. You take all denominators. So here we have 2 denominators. We have x and x minus 5. So what you do is you set each of those not equal to 0. Okay, now this one here is already solved because x is by itself, but this one down here, you kind of have to solve it a little bit here. So we're going to do the opposite. We're going to add 5 to both sides. So this tells me that x cannot be 5, cannot be equal to 5, cannot be equal to 0. So in the case that we do run into 0 or 5, we know that that answer is no good, okay? Okay, so here we go. That's the very first step. And then we get to the solving, all right? let me go ahead and copy this real quick. Okay, just so we have a little bit more space. Okay. Now, I'm well aware, because I've been teaching for a very long time, you guys were probably taught to, whenever you have this type of setup, to cross multiply, right? Don't write this in your notes, but your teacher probably taught you this, and then you got a magical answer, right? The issue with that is a lot of logic is lost, okay? So you want to make sure that you understand why that works, because this, although it's very easy to do in these type of problems, when you get into the more complicated ones, this whole idea of cross multiplying does not work. Okay, so I'm going to show you a move that works always. Okay, so instead of remembering 5 different moves, you're just remembering one technique. All right, so people tend to be afraid of fractions. Okay, let me just sidebar this real quick. If I gave you guys 1/4 plus 2/4, what does that give me? Okay, think about that for a second. Pause if you need to, press play whenever you're ready. Okay, so the rule here is when you're adding fractions, you have to have the same denominator. So that means that's just going to be 1 plus 2, which is 3, and then you keep the same denominator, right? Okay, so here's the thing. What I can do here is, let's say you're not a fan of fractions. What you can do is, if you see a 4 down here, you can multiply by a 4 up here. But the idea of balancing, okay? If you multiply by 4 here, you got to multiply by 4 here, and you got to multiply by 4 here. What that does, and again, you don't need to write this down unless you want to. What this does is it cancels out the denominator so that you're no longer dealing with fractions. So now if you take a look, even though I did that, I still get a true statement. So what that means is I didn't change the value of the problem. Okay? So I still get a true statement at the very end. That's what we're going to do over here. Okay? So we're going to try to get rid of our denominators here. So here's what we do. I see an x right here. So to get rid of it, I need to multiply by an x over here. But what I do to one side, I need to do it to the other side. Okay? But here's the thing. That'll cancel out that x, but then I still have this x minus 5 down here. So what I'm going to do is I'm going to multiply by x minus 5 so that I can cancel that out. But what I do to one side, I have to do to the other. Okay? So again, what happens here is that x minus 5 will cancel out. So if you notice, both denominators are now crossed out. What you multiplied by here was called the least common multiple. But don't worry if you don't remember that phrase. Just think about, well, what do I need to multiply to get rid of all of my denominators? Okay? So here we go. Let me get rid of all the arrows so that you're not confused. So we multiplied by each of the denominators, each of the factors, so that we can get rid of the denominators. What you have left here on the left side is an x minus 5. You have an x plus 6. You have a 2. And you have an x. Everything else is good. Now you're not dealing with fractions anymore, right? Which makes things a little bit easier to deal with. So here, you guys have been spending weeks and weeks on quadratics, right? Go ahead and take care of the left-hand side here, however you'd like. And then press play when you're ready or if you're stuck. So here, some people like to do FOIL. Some people like to just draw arrows, right? Some people like to do the Punnett squares. Look back in your notes if you need to. I like to just draw out the arrows. So x times x is x squared. X times a positive 6 is a positive 6x. Negative 5 times x is a negative 5x, and a negative 5 times a positive 6 is a negative 30. And on the right side, 2 times x is just 2x. Okay? So again, we're going back to quadratic, so you want to make sure that you guys are really comfortable with that, okay? Okay, so here we go. I noticed that I can combine these two because they have the same variable in the same degree. So that's going to be plus 6 minus 5. Different signs we subtract. We keep the sign of the larger number. That's just a positive 1x. You don't need to put the 1. I'm going to bring down the minus 30 and the x squared. Okay, so anytime you guys are solving quadratics, remember, it's a quadratic because we have a square here, okay? Anytime you guys have a quadratic, you want to make one side equal to 0. So how do we do that, right? Well, to move the 2x over here, I need to do the opposite. So the opposite of a 2x is a negative 2x. And what I do to one side, I do to the other. Now, it can only combine right here, so I'm going to put that right in the middle because they're both linear terms, okay? Okay, so here's what we have. We have x squared, positive 1 minus 2, that's negative 1x minus 30. Okay, so now we have our 0. What we're trying to do here is we're trying to use the 0 product property here. So we have our 0. We need our product. So product means that we got to factor this somehow. Okay? Pause here. Spend as much time as you need, and then press play when you have it or if you're stuck. Okay? So you know that the factors of x squared is just x times x. So there's not a lot of variation here, so I could put that in there. What multiplies to negative 30? Well, I'm going to try, I could do 10 and 3, 15 and 2, 1 and 30, 5 and 6. But remember, your goal is to get negative 1. So I know that I can do that with negative 6 and positive 5. Because negative 6 times 5 is negative 30. And negative 6 plus 5 is negative 1. Okay? Now, if you're struggling with factoring, just talk to me. I'll help you out. I'll give you some more problems to practice, okay? Now that we have a product, because we have something times something else here, equal to 0, we could use the 0 product property, which allows us to split, to set each factor equal to 0. Now, some of you can skip this step. You could see the answers already. You can find your zeros already. But I'm just going to show the work just so you guys can see it. Here, I'm going to have to subtract 5. I have to do the opposite. So x here will equal negative 5. Here, I have to add 6. So x would have to equal positive 6. Okay? So here's what you guys got to do. We have two answers, negative 5 and positive 6. All you have to do right now is double check your domain. Did your domain include a negative 5 or a positive 6? It doesn't. Notice how x can't be 0 and 5. So there are no conflicts here. Okay, so because you didn't run into your domain, you have two good answers. So I'm going to go ahead and box this. Now let me give you an example. Let's say over here you came out to x equals positive 5. Okay, if you had something like that, notice how at the beginning we said that x can't be 5, right? So you wouldn't box it. You would instead call it an extraneous answer. It's pretty much an extra answer that does not work. Okay? And that's it. Now, the old school way was taking your two answers, going back to the very beginning, and plugging in your x values, but that takes forever. So if you check your domain first, you guys can save yourselves a lot of time, okay? All right. Replay that as much as you need to. Let's practice a little bit here. Here's part B. So here's my question to you. I want you to press pause after I ask the question. What is your very first step? Press play when you're ready. Okay? Your very first step is not to solve, you guys. Your first step is to check your domain. Okay? So make that a habit. Okay? So we're going to set our two denominators equal to 0, not equal to 0. So -4 not equal to 0, and x plus 6 not equal to 0. Okay? So let's solve this one over here. We're going to subtract 6, so we know that x cannot be -6. Now over here, notice how there are no variables. -4 cannot be 0. That's what it says, right? If you think about it, that's called a constant because there are no variables next to it. So we don't have to worry about -4 becoming a 0 because -4 will always be -4. But when you have variables in the denominator, you got to watch out for that. So the only restriction here is that x cannot be -6. So I'm going to highlight that. We'll come back to it later if we need to, okay? All right, so our second step, get rid of your fractions. If you don't like it, get rid of it. So if I want to get rid of my denominator -4, I'm going to multiply by -4. But what I do to one side, I have to do to the other. Okay? That gets rid of this, but it doesn't get rid of this yet. So what else do I have to do, right? I'm also going to have to multiply by an x plus 6 factor. But what I do to one side, I have to do it to the other. That allows me to cancel out these two. So notice how all denominators are reduced out, okay? So what do I have on the left side here? I have x plus 6 and an x minus 3. On the right side, I have a 5 times a -4, which is just -20. Okay? Now, some people would like to use the zero product property. We do have a product here, but you guys got to keep in mind we don't have our 0. Okay? So you can't use a -20 product property. Okay? That's probably the #1 mistake I see. So what we're going to have to do here is expand this. Okay, go ahead and do that and press play when you're ready. So you should get x squared minus 3x plus 6x minus 18 equals -20. Okay, I noticed that I can combine two terms here. That'll give me a positive 3x. I'll bring down my x squared and my minus 18 and my -20. Okay, I have a quadratic equation because of the little square here. Okay, so to set it up for the zero product property, let's get my 0 first. What do? I have to make a 0, right? So I have to move the -20 over. How do I do that? I'm going to have to do the opposite, which is add 20. And what I do to one side, I do to the other. Now, 20 can only add with which term here? Okay. You wouldn't put it here because 20 doesn't have an x. And you wouldn't put it here because 20 doesn't have an x squared next to it. So since it's a constant, you have to add it with the other constant. Okay. So check it out. I have my 0. Okay. I have x squared plus 3x. -18 plus 20, different signs we subtract. We keep the sign of the larger number. We should get positive 2. So we have our 0. Now we need our product. So we're going to have to factor here. Okay, press play whenever you've factored it or if you're stuck. Okay, so this right here is just x times x. This right here is just 1 times 2. So I know it's going to be x, 1, 2, and since everything is positive, I'll just put plus plus. All right. So you can split now that you have a zero product, okay? Or if you want to speed this up a little bit, you'll notice that x has to be -1 or -2. If you think about solving that mentally, you just think about the opposite value. It's easy there, but when you have other cases where there's coefficients, you might want to split and solve there, okay? Okay, so these are answers, but we have to make sure that these answers are good. So are there any conflicts to our domain? Our domain says that x can't be -6. Well, do we have -6 over here? We don't. So we have two perfectly good solutions. Okay, and that's it. All right. Okay, here's part C. I want you guys to go ahead and try the whole thing and then press play whenever you're done or whenever you're stuck. Okay? Go ahead. Okay, first step, remember, you check your domain. You don't go into solving just yet. So right here, I set my two denominators, x and x plus 6, not equal to 0. I want to make sure I don't run into undefined values, okay? So here, x is already solved, so x can't be 0. And here, if you solve it, x can't be -6. So these are our two restrictions. Okay, we want to make sure that our final answers don't have 0 or -6 in them, okay? All right, here we go. So I'm going to multiply by x to get rid of this denominator, but I have to multiply by x over here to balance it. But I also need to multiply by x plus 6 to get rid of this, but then I'll need to do another x plus 6 on the left side here. Again, don't cross multiply. There's a reason why I'm telling you not to do that, okay? Cross multiplying does not always work, which is why I'm discouraging you guys from doing that, all right? Here I have x plus 6 times the quantity x minus 4 equals -8x. Okay, so here I'm going to go ahead and distribute the left-hand side. I should get x squared minus 4x plus 6x minus the 24 equal to -8x. Okay. I notice that these two terms can combine. That's going to be positive 2x minus 24 equals -8x. So now that I have a quadratic, I want to make sure that one side is equal to 0. Whoop, where'd it go? Okay. So I want to make my right side 0, so what I have to do is I have to do the opposite. I have to add 8x to one side, but I also have to add 8x to the other side, and it should be right here because they're both linear terms. All right. Right side will now be 0. I have x squared, same signs we add, plus 10x minus 24. Okay. So we have our 0. We need our product to use the 0 product property, right? So here is x times x, so I'll put that in there. Now here is a -24, so I could do 1 and 24, 2 and 12, 3 and 8, 4 and 6. Okay? But I want to end up with a positive 10x. So I know that 1 and 24 will probably not work, and 3 and 8 will probably not work, because there's no way of getting 10 out of it. Okay? Now here's a big misconception. It could either be 2 and 12 or 4 and 6. Now remember, you have to multiply to get a -24, which means that one of the values have to be negative and the other one has to be positive. So look, if I did positive 4 and -6, that gives me -24. But if I add positive 4 and -6, that gives me -2. Okay, so you guys got to be really good with your signs here. So 4 and 6, although it's tempting, although it looks like it'll give you 10, it actually won't here because of the signs. So 2 and 12 would work better. I want to end up with more positive, so I'll put positive on the larger number here. And I'll put a minus sign there. Because if you take a look, that gives me 12x. That gives me negative 2x. That gives me positive 10x, which is what I want right here. So take your time there. Don't feel like you have to rush it. I would rather you guys just be consistent than inaccurate, okay? So here you could look at it mentally or you could write it out. We could now use the zero product property. We could set each factor equal to 0. Okay, so this will tell me that x will equal 2 and that x will equal negative 12. Okay, now before I box these, do these two answers conflict with my restrictions? So we said that x can't be 0 or negative 6. Do I have 0 or negative 6 here? I don't, so there are no restrictions, no extraneous solutions, so I have two perfectly good answers. All right. Cool. Let's keep going. Let's skip this one. Let's do this last one here. All right. Go ahead and write it down. Press play when you're ready. Now, this looks a little bit weird. Some of you might notice that there is no denominator here, okay? That doesn't make it any more difficult. Actually, it makes things a little bit easier, okay? But nevertheless, the first step is to do what, right? Okay, we don't solve anything yet. The first step is to check your restrictions on your domain. Okay, we set all denominators not equal to 0. I only have one denominator here, so it's x minus 6. Cannot be 0. So that tells me that x cannot be 6. Okay, so we're going to have that in the back of our mind. X cannot be 6. Okay, so now we get to the solving. We don't like fractions, so let's get rid of it. So if I have an x minus 6 denominator, I'm going to multiply by x minus 6. But what I do to one side, I have to do it to the other. Okay, that allows me to cross out my denominators here. So even though this was missing a denominator, it actually makes your problem even easier than that, okay? Less work. So if you take a look at the right side, all you have left is just a negative 4. On the left side, you have an x minus 6 and an x minus 1 multiplied. Okay? So let's go ahead and distribute this here. We get x squared minus 1x minus 6x. And negative 6 times negative 1 is a positive 6. Take your time. You don't have to rush it. Okay. What do we do next? We could combine like terms right here. That's x squared. Negative 1 and negative 6 are same signs. Same signs we're going to add and keep the sign of the larger numbers. So that's negative 7x plus 6 equals negative 4. So now we have a quadratic, okay, because of the square. So we want to try to use the zero product property. The first step is to get our 0. How do we get our 0 here? Well, we have to move that negative 4. And we always move things by doing the opposite. Now, if I add 4 on one side, I'm going to have to add 4 to the other side. I should add it right here because it's a constant, okay? So every problem is a little bit different. So now I'm going to have x squared minus the 7x positive 10. I have my 0, but I need my product to use the zero product property. So this is going to require me to factor. Okay, pause here. We did this a while back, so feel free to go back and look at your notes. Okay, so we know that the factors of x squared are just x times x, so that's easy. Now this one is a little bit tricky. The factors of 10 are 1 and 10 or 2 and 5. Now in order to get some type of 7, obviously we're going to use some version of 2 and 5. Okay? Now remember, when your constant is positive, that means you're going to have the same signs. It's either going to be plus, plus, or it's either going to be minus, minus. Okay? We're going to have the same signs. So the only way to get negative 7x is if we deal with a bunch of negatives. So negative, negative, 2, and 5. If you put positive, positive, you're just going to get positive 7x when you add it. Okay? So I'll show you here just to prove it. Our outer, x times negative 5 is negative 5x. Our inner is negative 2 times x, which is negative 2x. And if I add this up, since they're the same signs, I add it, and I keep the sign of the larger number, which is exactly what I want. Okay? Now, if you're not getting what you want, that means you got to go back and keep guessing and checking, okay? Now that we have a product that's equal to 0, we can use the zero product property. Okay, which allows me to set each factor equal to 0. Okay, so that tells me that x will equal 2 and x will equal 5 once you solve it. Okay, now are we done yet? We got to make sure that we don't run into our restriction. Here it says x can't be 6. Do we have 6 here? No, we don't. So we have 2 perfectly good answers. Okay, you might be asking yourself or telling yourself, well, it doesn't seem like we ever run into the restrictions. You guys will eventually. Okay, you're just not there yet, but I'm training you guys to do all types of problems, all right? So remember, first step, always check domain before you solve, okay? Work on your distribution and then work on your factoring. So it's really nothing new. We've learned domain. We've learned how to multiply. We've learned how to factor. You just got to get really good at it again, okay? So go ahead and try the Delta Math assignment. I'll be there to support you. Just text me if you guys need it.